My name is Crilly, Director of Product Management within the NGINX Business Unit at F5 Networks. This talk is about API management. In particular, I'm going to cover NGINX Controller, the API management module for Controller. And just to understand kind of who we've got in the room, who has used or has looked at using NGINX Plus or NGINX open source as an API gateway? We get some hands. And who has seen NGINX Controller, or used it even, that's not working for the product team that's building that software? All right, I did see one or two hands, so I'm going to assume that for most people this is your first view of it, so I will run through the exciting demo aspects of the talk with that in mind. So thanks for level setting for me. Oh, well, then you should probably go and sell another product you haven't seen. Perfect. All right, so I'm going to start out by saying, first of all, actually, we heard a lot about microservices in general and this morning, but I'm certain that microservices is not a journey. There's been a lot of talk about going from monolith to microservices, and with the assertion that microservices is where we need to get to, that it's the end game. And I disagree. So it's in the last 4 or 5 years, and in a large part spearheaded by Netflix and the big tech companies and those with the resources and the smart people to do it, have taken microservices as an architectural pattern, who have built their own processes, built their own tooling and software to enable them to get the benefits of microservices. And there are many. We know that. It's a good thing. And what's happened in that period of time is that we've now got, for mass adoption, for every organization, every enterprise, the processes, the best practices, the tooling, the software you need to deploy microservices and make it run in production at scale, securely, and reliably, which is great. So we've met that point. And where we are now is that we can embrace both options. Right? So it's not about going from monoliths to microservices. For some application types, it's absolutely the right thing to do. For others, it's not. And now we have this tooling, we have the infrastructure, we know what we're doing, we have the best practices. We're able to make a choice. I've got a new application I need to deliver. Should it be microservice architecture? Should it be a monolith architecture? Yeah, and there are others too. But I'm making the point that it's a situation if we've arrived at, as an industry as a whole, where we've got solid choice in front of us. And this is borne out by some stats from the this year's NGINX user survey of the community that we know and love. They're telling us that 85% of them are running microservices in their organizations. But they're also telling us that 60% of those organizations, and I'd like to think that the NGINX community is a more forward-looking part of the industry as a whole, 60% are using monoliths. Right? And this is good. This is okay. This is a choice we have. So there's another stat that elsewhere in the survey which tells us that 95% of the new projects that our community is starting are microservices. And I think we're going to see that decrease. Right? For lots of organizations, it's their first opportunity. A new project comes along, they get to try microservices at last. Right? They get to put it in their environment and see the benefits for themselves, see how it fits their organization, how their culture, their processes, and maybe helps them move some digital transformation forward, be agile, and move faster in general. I think as time goes on, so I'll make a prediction, we will see that greenfield choice reduce from 85, 95% down to maybe 60, 70%, right? So people, once you've understood the benefits, you've understood the challenges, you then can make a nice balanced decision. So if and when you do choose microservices for your new application, you have to acknowledge that it comes with some challenges, right? There are particular challenges that come with microservices, and they're all related to the fact that microservices gives you a distributed application, distributed environment. API management gets distributed. The infrastructure itself that is running the data, handling the requests, running the traffic, that gets distributed. And the governance about how you secure, deploy, run all of this is also distributed. So I'm going to touch on these 3 challenges, and we'll look at how API management module for Controller helps address them. So, API management, first of all. So what happens with API management is that we go back sort of pre sort of microservices mass adoption. Our API management programs look like this. We've got centralized API management infrastructure. We've got an API gateway that's handling the traffic. You can think of it as a fancy, an API optimized ADC. And then we've got a monolith, probably SOAP XML based, running the business logic, running the code, exposing the data, whatever it is that it's doing. Fine. With microservices, what happens is, as you know, that application gets distributed. We've now got multiple, maybe 5, 10, 20 or more microservices delivering that same set of data, business logic, whatever the application happens to be. So the way in which we manage and configure on the API management side needs to adapt to accommodate that. So with that, let's take a look at the NGINX Controller UI, and I'll set some things up and we'll do some microservices stuff to set the scene. Let's get out of that. Mirroring, good. Okay, so here's controller. I'll point out I've got internet connectivity, VPN connectivity, and a bunch of other stuff that I'm depending on here, but everything looks like it's still up. I'm going to log in. Also notice along the way in my typing will probably struggle to keep up with my talking. Okay, I'm logged in. This is the controller UI. For those that haven't seen it before, we drop into initially into the analytics area. So we see we've got on the left-hand side one API gateway, which is an NGINX Plus instance. We can click on that and look at some of the information about it. We've also got an inventory, so I might have a number of these gateways, of course. It's a nice, simple demo environment. I can see that it's a Debian running the latest release of NGINX Plus. Great, and it's also been handling some traffic over the last hour or so whilst I've been having lunch. Now, under the API management tab, we have 3 APIs that we're publishing here. And as you can see, it's a sporting theme. So we've got baseball stats, golf data, and F1 results. Now, the golf and the baseball are deployed. They're running monolith-style APIs for the sake of this demo, and they're both being published on sports.example.com, which is the entry point, the way that which clients address that those APIs and where the API gateway is listening on. But what we haven't set up yet is the F1 results data. So I'm going to go through that and show that as a microservice. So we edit that definition. We'll see that we've got a title, we've got a base path, and we've got a number of resources that comprise this particular API. Different elements, different aspects of data, and each of these have a microservice that supports it. So in order to publish this API, we're going to add an environment. So an environment is the relationship between where the app is actually running and where the API gateways that come together to offer that externally. So we link that with the API definition itself. And in this way, we can take one API definition and we can publish it across multiple gateways, multiple times, different policies. We're going to keep it simple for this demo, though, and just do one. Right, so this is actually running already. So it's going to be on a laptop. Everything's better with an emoji, and this is going to be the F1 environment. Save that. Where are we going to publish it to? We have a sports services entry point. That, as you saw, is the sports.example.com host name, so that's what it looks like on the network. Skip past policies, and now let's do the routing. So, /current relates to the current season, so that's part of the results microservice, and that's published here. Let's do the next one. Seasons, again, that's results information. Save that. So you can see the different resources, different URIs that make up the API have different backend microservices, and we can here do in a visual way, we can do the routing that's necessary. Let's hope I didn't duplicate any of that. Finally, drivers, and that has its own drivers microservice. So with that done, and confirm that I do want that on the sports services entry point, I can hit the publish button. If I flip back to API definitions, I can see that that is now just published. Again, on sportsexample.com. So we've got one entry point with one API gateway that I showed you at the beginning, publishing 3 separate APIs, and we can just test that is going to be, that's working. Before I do that, let me show you just the here are all the upstreams with different backend servers. And for example, the results microservice has an IP address and a port, and we can have multiple of these. But then things start to get very gnarly on my demo environment. So let's flip to, let's see, we'll use Safari. And it was on port 443. Looks like I've been here before. /API F1 circuits. Should we save my typing? We'll look at the, the data for one particular circuit, if you can read that. There we go. Okay. Actually, I'm just going to repeat that because most of the other bits of the demo are going to be command line based. Hope that's big enough. And I will cheat by grabbing that there. So let's do this so we can see it in a nice. All right. We have an API that's published, and it's routing different URIs to different backend microservices. Kind of basic setup. And I've talked about API definitions. We can publish those to different API gateways. The upstream groups, which define where the code's actually running and how that's scaled out. Entry points, which define the network addressable component that the clients connect to. And then client groups, which are related to authentication, and we'll keep that out of scope for this demo right now. So, moving back on, I will set the scene. Second challenge we have is that the infrastructure with microservices environments gets distributed too. So, previous example, we have one API gateway that's running all three APIs. That's kind of neat. It's useful to be able to scale out like that. But when we're taking microservices into production and when we're trying to go fast, we're trying to do a digital transformation, then DevOps processes help us do that and they help us move faster. But at the same time, DevOps can be a little bit Wild West. It has a lot to answer for. These guys set up and they are fully empowered, fully autonomous, and they go racing ahead and they want to own and run and deploy all their own infrastructure. They want to make all their own decisions, which is great. They can go and do that. But this requires technical alignment, architectural alignment. So we need to make sure that the platform that we're deploying our APIs into is able to cope with the pace and the distributed nature and the autonomous nature of DevOps teams. So this gives me a short excuse to drill in a little bit onto the architecture of the way that NGINX Controller product is built, deployed. So as we've seen already, we've got a separation between the API management element and the API gateway. Right? So on the left-hand side, we've got the controller component that's built from the user interface that I've been using, which makes, calls into a core API to actually make backend changes and persist that configuration and persist that intent onto a database that's highly available. And on the other side, we've got the API gateway. So ostensibly, this is running NGINX Plus as an API gateway. It's arguably the world's most widely deployed API gateway, given how frequently it appears in other API management vendors' products. And the fact, as mentioned earlier, that 47% of our existing customers are using it as an API gateway in isolation without that API management wrap around it. So there's a lot of goodness in there. The API gateway itself then is running NGINX Plus to handle the traffic. It has the small agent component, and this is the component that talks to a controller. So whilst NGINX Plus is running handling traffic, there's no runtime dependency against the controller at all. So it can quite happily run without any comms between the agent and the controller. Of course, the stats which are exposed by the NGINX Plus API are collected by the agent first before being sent back to the controller. So if there is an outage, they get buffered up there until such time as it's available again. Similarly, in the controller user interface, you'll see that the ability to publish a configuration and push a change requires availability of that instance. So we will mark it as red. We won't allow publish to happen if the controller knows that there's a temporary partition. So you don't accidentally try and make a change that cannot be executed or cannot be implemented. And this, of course, then scales out. So we've got a dozen API gateways all sending the traffic back. They're all able to run autonomously and independently, which is the same way that you want your DevOps teams to operate. The other architectural challenge that happens is we go from having NGINX Controller running the API management platform, deriving the configuration, onto the NGINX Plus API gateways for a number of APIs. But in a microservices environment, especially in a DevOps-focused environment, you may have each team running an API gateway for their own service or set of services. And so what I want to show you is taking that example with Controller. So I'm going to take that new API that we just published. Currently, it's running along with all the other APIs on that platform, and I'm going to give it a dedicated API gateway. Let's do that. So the very first thing I'm going to need is an API gateway. And thanks to the beauty of Docker, I can just spin one up. So let's have an API gateway 2. The same host name, so it appears nicely in the UI. We'll let Docker choose the ports, and I've got an NGINX Controller demo instance ready to go. So I'll fire that up, and while that's establishing itself, remember that I now want to publish this F1 API on a separate API gateway. So I'm going to create an entry point for that. It's going to need to, I can't reuse sportsexample.com. The network routes that to one particular place. So I'm going to create a new entry point. And this is going to be, let's say this DevOps team is looking after all of the motorsport services, not just F1, maybe they'll do some other stuff too, like MotoGP. Of course, I have to now type that. Motorsport services. I asserted that everything's better with an emoji, so we'll have one of those too. And forgive me, but I'm going to use the acronym of Formula One Oversight to publish this. Maybe I didn't have all the host names I needed. And again, we're in production here, so we're going to not do plain text. We're only going to do TLS, port 443. Let's give it a cert. There's the cert. And let's give it a private key. And again, what's happening here, if I was, let's say I could have 5 of these API gateways published through this entry point, and I just do the certificate upload once, and the controller takes care of pushing it down everywhere else. I will use the TLS configuration that I've used elsewhere. So that's just a selection here. You can see it tells me what kind of TLS policy and configuration is going to go on. And now I should be able to pick up the API gateway 2 that I just spun up in Docker. So that's done. And save it. And now I've got 2 entry points, but you'll see the sports services entry point is still running all 3 APIs. So now, let's go to my API definitions, edit the environment for my laptop F1, still running in the same place, but now I want to have a dedicated API gateway for it. So instead of the sports services entry point, I want my motorsport services entry point on the foo.example.com hostname. So save that and publish. And then we'll see that it's publishing now. That's done. Notice that actually it published all of the APIs again. And that's because we need to remove the configuration that we previously had on the original API gateway so that it only now appears on API gateway 2, which is running the foo.example.com entry point. Let's see if that's the case. So I'm going to rerun that same command, and I can no longer access my F1 API on the sportsexample.com hostname. I should be able to access it on the foo.example.com hostname if I figure out what port that's running on. So let's, there we go, 32.14. Formula One Oversight, remember. And let's choose something else, like drivers. Anyone got a favorite driver? I'll choose Lewis Hamilton. I thought we were going to go for an American, but okay. 404. And it's a plural driver, I think I need there. There we go. All right. So, with a couple of clicks, we've now flipped from running 3 APIs through one API gateway to isolating one of those APIs, giving it to a DevOps team, allowing that DevOps team to have its own API gateway and its own piece of infrastructure and its own cloud, wherever it happens to be running its code. So we can have the gateway close to the application code without needing that to be centralized. We've got centralized control through the UI through controller, but distributed traffic. Okay. So, the third challenge we have with distributed microservices environment is that governance get distributed. And this is kind of one of the gnarliest ones to deal with, especially because it's as much about policy and process as it is about technology. And we look at a recent survey by IDC, we see that security governance is the #1 feature that people are looking for when they're looking for an API management solution. So that's no surprise. It's even less of a surprise when we consider the challenges that present themselves with API, with the microservices style of API management. All right, so I'm going to touch on one such example. So what we're going to do here is, let's pretend that our 3 sports services are actually, rather than being public without authentication as they are now, that they're private. And not only are they private, I need a credit card to access them. So they're subscription services, and I therefore fall under the governance requirements of the payment card industry. So the PSI DSS legislation applies to me. And not so long ago, they said that you can no longer use TLS 1.0 for handling that kind of traffic. Let's fast forward a little while, and let's say that TLS 1.1 is also no longer allowed. So what I want to do here is take all of the published APIs across all of the gateways they happen to be running on and make sure that they are all compliant with the TLS policy that I need. So, one more time. So you remember that when I set up the entry point for the F1 for the foo.example.com hostname, I chose an existing TLS policy, but I specified the specific certs that match that hostname. They are part of a TLS policy. I've got one here, and I can see that I've got TLS 1.0, 1.1, and 1.2. So I'm configured for maximum compatibility, right? And this is has some other attributes associated with it, and it's used by 2 entry points. So I can do a stroke here. I can say I should never have been allowing TLS 1.0. I'm now no longer allowed to have TLS 1.1. I'm going to save that, and my changes are going to be applied to all of the APIs published through the linked entry points there. So what I will need to do is remind it to do that and publish. Soon to be automated. And once that's done, I can go back and make sure this still works. Of course, by default, I'm sending a modern cipher here. But if let's make sure that if I use TLS 1.2, everything should be good. If I use TLS 1.1 or 1.0, no longer good. And the error here is to do with incompatible TLS version. So what we're getting to here is whereby you can have a security team, an IT team that's responsible for having that centralized governance over all of the APIs that are published, allow the DevOps teams to operate in their own infrastructure with their own programs, whilst adopting the policy that's laid down from the security team. And when that policy changes, it's simply a case of adjusting the policy that you want, applying those changes, and the entire infrastructure is affected. We should also see, if I go back to the graphs here, that we've got traffic's been flowing through in the background the whole time, which is probably why my battery is not charging. And the new API gateway that just came online a few minutes ago, literally 5 minutes ago, has now seen a little bit of traffic that we've been sending to it. All right. So I started off by saying that microservices is not a journey. Right? It's now got to the point where microservices is a choice. It's a great choice. Don't get me wrong. I'm not trying to say we should be doing monoliths forever, but it's we have the tools we need, the infrastructure we need, software the best practices and the experience that we need to know when's the right time to build a microservices solution, when's the right time to choose something else, and to know what the challenges you face, the pros and cons of each of those architectures are whenever you deploy it. So with that, thank you for your attention. We do have a few minutes left for any questions. Thank you. I don't know if there's a mic, but it's a small room, so if there's any questions, please. Yeah.
So in this model, you have the agent running and you have the controller. When you're trying to deploy this, you can have like a centralized controller. What happens if you want to deploy the gateways in like the Docker Swarm or the Kubernetes Swarm? Do the agents connect to the controller, or is there connectivity the other way around?
So the way that it works is right now is that the agent connects out to controller. So what you saw me do with, when I spun up a simple singular Docker container, that has the address of the controller baked in. So it connects in, and then that's why it appeared automatically in the controller UI, so it knows that it's there. And then you can then choose to attach it. We'll be adding more Kubernetes scaled out or Docker Swarm capabilities so that you can deploy, for example, the API gateway as the NGINX controller. So it can be doing all these functions right at the edge of the cluster. Or it can be something that you delegate to operate deeper within the cluster. You have the choice. All right, no other questions. I'll be around all through comp, so please come and grab me if anything else occurs to you. And I think we'll have a couple minutes downtime before the next one. Thanks again.